NaOH. Oh wait. Okay. Sorry. My bad. Bruno. Okay, so it says spawn NaOH. Conduct NaCl neutralization reaction. Okay, so more sodium, more sodium, more chlorine. Another chlorine. I don't know what I'm doing. Ooh. What's the given task? Let's conduct the NaOH plus HCl yields sodium chloride plus water and sodium hydroxide plus when acids and bases are placed into the same place, they react, and in this reaction, acids and bases neutralize each other to make salt. While acids, H plus cation, and bases, OH minus anion, combine together to form water, the anion of acid and the cation of the base combine together to make salt. Okay, so let's clear that. And then we have, that way it's not so messy, hydrogen chloride. So let's look for hydrogen chloride. This one. There we go. And then now, let's see. Yeah. Okay. Dissolve sodium in water. So I think I need H2O, right? I need H2O. And then I can create this. But let me clear that. Okay. Let me try something. H2O and sodium. Okay. So I think I need something like this. To create this. To create this. To create this. I don't know what I'm doing. Dissolve sodium in water. How about this one? Dissolve sodium in water. gonna go to this one and this one, H, and then add a hydrogen. Add 2 hydrogens and do the reaction. Okay, I really don't know what I'm doing. I'm trying to get sodium to dissolve in water. Why don't I do something else? Spawn calcium hydroxide. Okay. So calcium hydroxide. Calcium chloride. Light clear. Calcium chloride. This just gave me an idea. I'm gonna go back and try to do the other one. Oh my god. Spawn. Calcium hydroxide. So technically we're going to take 8 calcium bases calcium chloride and then add sodium. Let's try adding sodium to that. Another sodium. And yet another sodium. And another sodium. No. Okay, it doesn't. That did not do anything. I'll be right back. Yeah, I'll be right back. calcium hydroxide. Okay, conducts calcium CO3. Says spawn COH2, so 2. Blah. Trying to make calcium hydroxide, I think. Let me start over. Okay, so calcium. How many? Okay, so we see that stable isotopes, electrical resist. Wait, let's go back to molecules and this one, calcium oxide. Calcium oxide with water, maybe. Let's see what happens if it mixes with water. Yay, I did it! So what I did there to do that, I took a calcium. So let me do that again. So I took a calcium oxide. Then I mixed that with water. And then that created calcium hydroxide. So then now we go back and need to dissolve Na in water. Sometimes I realize that some science experiments are very simple. You just have to think about whether it should be mixed with a water, a base, or an acid. Okay, so spawn H2CO3. H2CO3, okay. H2CO3. Carbon. Oh wait, it's right here. Okay. Conduct. Conduct sounds like fire. So we're gonna oh my god. Keyboard's hot. Conduct CaCO3. Calcium carbonate? I think I need like electricity. Let's see, I don't know. So what do we have? We have a CO3 double bond here. I don't know if that helps. How about water? Mix it with water. Conduct CaO3 neutralization reaction. I don't know what I'm doing. How about spawn H2SO4? Okay. Spawn conduct reactions produce. History of the periodic table. In 1649, Henning Brand discovered the first element that he named phosphorus. He discovered phosphorus by distilling human urine. Later scientists learned much more about the idea of elements. By 1869, 63 elements were discovered and scientists started to see a pattern within elements. John Newlands and Alexandre Emily Begayer de Chancourtoy made their own tables that were simple but hard to understand and read. Then in the following months, Dmitry Mendeleev sorted elements by their atomic mass, thus making the first version of the modern periodic table. In the process of making the periodic table, he realized that there were elements that hadn't been discovered at the time. For that reason, he left spaces in the periodic table to be filled. In 1945, the Manhattan Project yielded the results of radioactive elements. Glenn T. Seaborg suggested changing the periodic table to add lanthanides and actinides to the periodic table. Combustion reactions usually happen with oxygen, but it can be conducted with either oxidants such as fluorine, combustions happen quickly and emit heat, light, and fire. Oxygen gets into combustion reactions when met with metals to oxidate metals, which makes rust on metals. This type of combustion is known as slow combustion. Combustion reactions are a type of redox reaction. Water, so like, I guess in this case we have methane plus 2 oxygen yields. So water and metals make combustion. In this case we have a metal, it's methane, or actually no, methane is a gas. So methane plus oxygen combustion reactions usually happen with oxygen, but it can be conducted with other oxidants such as fluorine. Combustions happen quickly and emit heat, light, and fire. Oxygen gets into combustion reactions with metals to oxidate metals, which makes rust on metals. This type of combustion is known as slow combustion. Combustion reactions are a type of redox reaction. Water dissolution reactions are subdivided into 2 categories. These categories are ionic molecule dissolution and covalent molecule dissolution. When ionic molecules dissolve in water to its ions, the solvent surrounds these ions. When covalent molecules dissolve in a similarly structured solvent, the solvent molecules surround the solute. The biggest difference between these 2 types of dissolution is that the ionic solutions are electrolytes that can conduct. So, as I understand, a metal and oxygen can make fire or heat. Like, according to this, combustion reactions usually happen with oxygen, but it can be conducted with other oxidants such as fluorine. Combustions happen quickly and emit heat, light, and fire. Oxygen gets into combustion reactions with metals to oxidate metals, which makes rust on metals. This type of combustion is known as slow combustion. I see. When covalent molecules dissolve in a similarly structured solvent, the solvent molecules surround the solute. The biggest difference between these two types of dissolution is that the ionic solutions are electrolytes that can conduct electric current in the water, while covalent solutions are non-electrolytes. When oxides dissolve in water, if the oxide is a metal oxide, that reaction will result in a base. If it is a non-metallic oxide, the reaction will result in an acid. In 1803, John Dalton surfaced the idea of atom, which was first thought by ancient Greek philosophers, and stated that atoms are indivisible. He also said that an element is made by the same atoms. Then, in the 1800s, J.J. Thomson discovered that atoms were in fact divisible and said that atoms are made of several little particles, and this atom model was later called the plum pudding model. Rutherford, to prove Thomson's model, made the gold foil experiment and found that the positive ions, protons, were actually at the center of the atom called nucleus. Niels Bohr later proved the existence of energy levels in shells of electrons and to further understand the atom, he used quantum theories. In 1926, Erwin Schrödinger discovered that electrons can both behave like waves and particles. Because of the electrons' wave-like nature, they can be found in orbitals, which are clouds of probability. In project chemistry, as a design choice, we render atoms according to the Rutherford atom model. When acids and bases are placed in the same place, they react, and in this reaction, acids and bases neutralize each other to make salt. While acids H plus cation and bases OH anion combine together to form water, the anion of acid and the cation of the base combine together to make salt. While analysis means to separate, synthesis means to form. Analysis reactions split molecules into two or more element molecules, while synthesis reactions do the opposite. Oxides are binary compounds, which consist of oxygen and an element. To count a compound as an oxide, oxygen has to bond with a different type of element. Okay. Let's go back. Am I smarter now? I don't know. Let's clear that, and then let's go back. conduct reaction to produce. Hold on, I'll be right back. itself. Calcium carbonate, or actually. So what is this? Huh. CaCO3. In the presence of let's try this. neutralization reaction. How do I neutralize it?